The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
But I'd like to now welcome up Dr. Saeed. I'm going to mess up your last name again. Fathali. You can introduce, yes, thank you. On quantifying benefits of seismic retrofitting gravity columns using CFRP jackets based on nonlinear modeling parameters.
Thanks very much for sticking around. I know that this has been a long convention and we are getting close to the end, so I really appreciate that you're making time for this session. For those of you who were around for the first session, we heard about what is being developed by academicians in different ways, one of them being ACI 369 that has sponsored this session. In my talk, I intend to show the impact of what is being developed for the practice. The presentation that I've prepared today, I'm going to talk about the background of what has led to this point, this presentation that I have prepared for this talk, and I'm going to show you the state of practice and how it can be benefited by what ACI 369 is developing. And I'm going to show you a case study based on what I'm going to present to you. And I'm going to have some concluding remarks for the ACI 369 members and the audience. So a couple of years ago, I had a presentation in a consulting firm in California to talk about seismic design with application of FRP materials. And at the end, one of the principals told me that you couldn't come here in a better time because I have a project. There are 3 parking structures in California that I'm about to put out the bids at. A large number of gravity columns of this parking structure are going to receive FRP material as the retrofit. So I was curious what the story is. I asked him to give me a background. He explained to me that the owner of these 3 parking structures intends to do some upgrade and has gone to the bank and asked for some loan. And the bank has appreciated that these are valuable assets, but currently in California, it's becoming more and more common that the lenders perform some kind of seismic loss assessment of the property that you want to sell, or they want to give a mortgage or any kind of loan based on that. So they hired one of the best loss estimators in California, and the first look, they looked into these parking structures. They learned that they were built in 1990, reinforced concrete moment frame on the perimeters, and precast slab and beams, columns with corbels, no issue with liquefaction. They learned that the 3 parking garages, they have been retrofitted after the Northridge earthquake for no reason but what I'm going to show you in the next slide. There wasn't any damage. They just saw things with other parking structures that they decided to do some partial retrofit. So putting all of this information together, the first look, the parking structure is in good shape and it should pass all of the basic PML scores. But the loss estimator of this project has been around for a long time, has seen a lot of things, including what we saw during the Northridge earthquake. You see 2 of the parking structures that they came down not because of the failure of lateral force resistance system, but because of the issue with the gravity systems. Their gravity columns didn't have enough confinement, or they had issues with the precast system. And to this day, the people who lived that earthquake, they remember these failures. So the loss estimator went back and looked into the existing drawings, and he could figure that the gravity columns, they have a number of issues. They lack confinement. A bunch of them, they are shear governed. So he went back to his special framework of doing PML and somehow managed to attribute a number to what will happen when these gravity columns are going to give up. He informed the lender that this building, although it looks pretty good in the first look, in the second look, has to be retrofitted. So when the information was sent to the lender informed the owner that you have to take care of these buildings before you are qualified to get a loan. And the owner contacted the people who had designed the parking structure at the first place. And this is a firm that is very famous in designing a lot of famous parking structures in California. The loss estimator presented a bunch of evidence to the original designer that these are the things that we see for with the gravity columns, that they have issue with the shear, they have issue with the confinement or detailing. And the challenge for the EOR became to work with the limited budget by the owner. Remember that the owner intended to upgrade the parking structures, and now he had to spend some money before getting qualified for that loan. So they had a limited budget, and the EOR had to work with that budget to address multiple deficiencies of a number of columns, and he understood that there is a lack of guideline, at least when it comes to evaluation of what will happen when he retrofits these columns. And you heard today, Wasim mentioned that one of the tasks that ACI 369 is pursuing is providing guideline how to evaluate retrofitted elements and how you can have acceptance criteria for that. So that was the challenge for the EOR, and also on the side of the loss estimators, there was this understanding that depending on what the EOR is going to cook up, the loss estimators may not be able to attribute a number to how much improvement through this retrofit is going to be achieved. But they started at one point, long before I met the EOR that day. So what happened was the EOR had heard about FRP and knew that the state of practice has evolved in a way that a lot of engineers, when they want to use FRP, they put together performance spec drawings. They basically explain what they intend to achieve with FRP, and the vendors and manufacturers, they have design assist, and they come up with the design calculations and shop drawings for FRP. So the EOR thought at that point that that is the route that he's going to take. He's going to just put together some drawings and ask people like my company to design the FRP. Before doing that, he wanted to double check his idea, so he called one of the vendors, not us, and explained the idea. But in that call, he realized something that he didn't know and he didn't appreciate. And he was told that when you use FRP around non-circular columns, the improvement of confinement is not as impressive as circular column. And he was shown the chart such as the one that I'm showing on the top. When we use the FRP material around the column, we go from F'(C) to F'(CC), which is the confined. But as you can see in the black chart on the right, when you go from the circular to other shapes, the benefits of confinement reduces. And this has been shown by the tests, as you can see in the damaged shape of the concrete column that was tested with the FRP, and also the diagram that shows when you go around something with corners, the confinement doesn't happen around the side as well as it happens for a circular section. So that was some kind of concerning news for the EOR. And he thought to himself that the way to get around that is I'm going to decide to have these columns to be jacketed with concrete first. And then when they are circular shape, I'm going to ask the vendor to design FRP. So that was the concept. Again, he called the same vendor and asked, can you come up with a number for this retrofit? Once he knew how much this is going to cost to make these columns rounded and wrapped with FRP, he also knew how much the budget is. Dividing the two numbers together, he knew that how many columns are going to be retrofitted. So at that point, it was just deciding where he expected to get the maximum demands. So based on engineering judgment, he came up with locations all at the first level, and he put together the bid set that these columns need to be retrofitted by jacketing and FRP in a way that they perform as well as a column designed today per ACI 318 would. So he showed me this, and he asked me if my company wanted to put a bid. And of course, we would welcome that. But through the discussions that I had with him and with the loss estimators, I realized there is this sense of lack of satisfaction about the entire thing, because there are things that we know that are listed over there. We knew that a number of these gravity columns are deficient. We knew that we are taking a step forward by retrofitting some of these, but we didn't know if we have targeted the right columns. We didn't know if we are using the budget in an optimum way. There was no way that we evaluate the design. And also the loss estimator didn't have a way to connect what is being happening inside these buildings to his calculations to reduce the PML. So I started to talk to the loss estimator before we put together a bid, and I asked him, I have a couple of tricks if he would be open to entertain those ideas. One of the things that I knew was all the FRP tests done on the columns, including the one that my company is doing. When you wrap even one layer of FRP around one concrete column, you get ductility improvement that regardless of like how much you are getting on that chart that I showed you, the improvement of ductility is impressive. So I told him, like, if I go through all of the columns of these parking garages and I check a capacity design that we are going to prevent the shear failure, and if I can show you that by wrapping one or two layers of FRP, how much ductility improvement I'm going to get, will you be willing to accept that design? Because the loss estimator was in charge of approving whatever that would be proposed. He was open to that idea, but again, he said, we need something like ASCE 41 backbone curve that evaluate what is happening, and I can plug it into my platform to come up with a number. Help me with that. And that was a point that I was lucky to be involved with ACI 369. I had heard through Sergio that Sergio and his students have worked to gather all the information, all the jacketed columns, and they were about to introduce backbone curves for FRP-jacketed columns. So I contacted Sergio and asked permission if I'm allowed to use this as an evidence when I talked to the loss estimator. He pointed to the paper that has been published, and I took that to the loss estimators, and I showed that this is what I intend to use as the backbone curve, which is I'm going to use the average of what has been seen in the tests. And obviously, this is something that if you have seen FRP and you have the knowledge of how things work, you can agree with that. This is just like all was needed to bring everything together. So using this information in the bid that we put as my company put, we mentioned that if we want to do the concrete jacket plus FRP per bid set, this is what we can do. There is another way to go around this. We can form a design build team with the original designer. We take the FRP design and we use the backbone curves and we establish the behavior of the building. We find which columns actually need to be retrofitted, and we help you to identify how much improvement you're going to get. The owner received the bid proposals and chose our proposal, and we formed the design build team with the EOR. My company took charge of modeling the buildings and performing nonlinear analysis on the 3 garage structures to establish where we need to fix these columns. Basically, using the ASCE 41 methodology, we established the roof target displacement. We looked at the demand on the columns at that level, and based on that, we designed the FRP. I mentioned to you that we had a couple of tricks. I showed you one of them was taking advantage of backbone curves. So we went back and we modeled the hinges using these backbone curves that if they were based on experimental study. A couple of things that helped us to be competitive was what we know about the FRP design that wasn't taken advantage of. Column with multiple deficiencies, these diagrams are from FEMA 547. The good thing about FRP is when you use them for shear, confinement, and lap splice, these things don't add up. I won't have time to explain how for those of you who haven't used FRP, but the thing is, you consider the columns in different segments. You have the hinge, you have the secondary hinge, and you have the detailing problem. At every segment of the wall, you figure out the worst problem, and you design the FRP, and that will solve all of the other problems. So that was one of the tricks that we used. And the other thing was, instead of shooting from designing the FRP to make the confinement equal to what ACI 318 would require for a special moment frame, we had established the actual demand on the columns. And there has been a procedure that we have used for years to design FRP for confinement, but now it's inside the ACI 440. So we had the standard, we used that, and we optimized the design of FRP. So at the end, we found some columns that they were left out in the original design because they were limited and they had put only FRP in the areas that they expected to get mechanisms. We found some of them they need FRP. We could show that they didn't need to do the concrete jacketing, and we could wrap the FRP around the square columns and get the performance that is needed. So we provide answers to those unknowns, and now having the actual behavior of the building was the thing that the loss estimator would need, and that was fed to his platform to come up with an estimate for the loss. So the project at this point took two different paths. One path was going through the local jurisdiction, provide them with the calculations. This was a voluntary retrofit, so it was a different kind of treating the project. And the other path was taking the information from an analysis, giving it to the loss estimator, and he could show that the proposed retrofit is going to reduce the PML to the numbers that would be acceptable for the loan. Because this is a private project, I won't be able to talk about the numbers of the actual project. So what I did for this presentation, I asked my friend in Europe, San Francisco, to help me do a loss estimate on something similar. The numbers are not the same as that project, so don't take it as these numbers reflect what is happening in that project. But I tried to construct an example to make the point here. So the example that we constructed with the help of my friends in Europe, San Francisco, we took a 5-story reinforced concrete moment frame in Los Angeles, built around 1990, and same problem, but 250 of gravity columns of this building are identified as deficient, and as a result of that, if you think about the schematic behavior, pushover behavior of the building, instead of having something like green at very low values of roof drift, you're going to have collapse of the building because of the gravity columns, like the pictures that I showed you from the past earthquakes. Using the probability of collapse assessment procedures that people at AT&R group of Europe has, we came up with a 20% probability of collapse for this building under DBE. And then Europe has developed this platform that is called READY, that is for probability loss assessment of buildings. They allowed me to use their platform to populate an example with the information of this building. And what we came up as a result was the median loss for such a building would be about $32 million. And the thing that I want to draw your attention to is the distribution of contribution to the total damage. Most of it is a result of the collapse that we were getting at the lower levels because of the gravity columns. And as a result of that, the contribution of damage in the upper levels is not that much. It's just because the building is going to experience a collapse over these buildings, over these levels. So just think about it that today, if someone wants to deal with this problem, again, they will think about FRP, and they will go out and say, talk to companies like mine, we want to wrap FRP around these columns. And imagine that they get a quote that it's going to be about $3,000 to retrofit these columns. And there is a loss estimator who asks the question like, how much is the cost to repair these columns after the earthquake? If we have to remove the FRP, inspect the columns, fix the cracks, and put the FRP again. And let's imagine that there is a quote for that about $7,000. Again, these numbers are imaginary. If we approach this problem today, again, we're going to be stuck without having access to something like ACI 369 to quantify what it means when we wrap these columns. But using that information again and using the same example, we could establish that we can reduce the probability of collapse to less than 1%. And again, using the fragility curves that already allows you to customize, we went back and created the same example, this time with retrofitted building. And the green chart shows the distribution of contribution of collapse at each level. What we could show in that example was the mean loss by spending about $0.75 million can be reduced from about $32 million to $7.2 million. These numbers are not correlating to that actual project, but these are very realistic. These are the things that, based on my conversations with companies like Arup, that they do loss estimate, they correlate with reality. So it's pretty significant that $0.75 million of initial investment for retrofit can reduce the loss so significantly. The other thing that you can see is, like, once you do the retrofit, the contribution of upper levels will increase. And the reason is you no longer get the collapse at the lower levels. Now you have things that we have populated the example with, like the precast panels and a staircase, that they will be damaged. They contribute to some of the damage. But you no longer have the issue of the collapse. For my concluding remarks, I want to emphasize the benefit and the impact that the effort of research done by and development that is done by ACI 369 for the actual projects that we pursue. And I like to encourage the committee to always look into finding the next best practical step. We always have the tendency of getting excited to find the most perfect tool when we sit around to find the formula that has the best correlation. But what I have learned doing a little bit of research at the same time of being involved with practice, the more you get far to the extreme ideas and you make complex ideas presented even more complex, you leave more people behind. So I think the most genius part of our work, as Albert Einstein once said, is to present complex ideas in a simple way, not the other way. For the audience of ACI 369, I think number one is I would encourage you to participate. If you're a structural engineer, you're a student, academician, there are a ton of things to achieve, and the more the merrier in this case. For the engineers, when you deal with an existing structure, when there is a baseline for a solution, these are perfect situations to pursue a design build that creates a win-win-win situation for everybody involved. One of the biggest concerns for the owners when you talk about design build is they worry like, what if the two conspire together to come up with something that is really crazy? But once you have a baseline, like in this project, then by allowing design build, you're basically encouraging creativity, and every time people will surprise you by coming up with better ideas. For the structural engineers beyond the now, as you saw in this project, by mere involvement in ACI 369 and knowing about the platforms like Ready, we were able to change the direction of the project altogether. From the business standpoint, we were able to win the project, ended up finding things that it was hidden in the initial design. And also, I have a cautionary note. I want to quote somebody that I like. Mark Twain says, like, most people use the statistics like the drunk man uses the lamppost. They use it as a support rather than illumination. So once you, the more advanced tools that we invent, we have this tendency to resign the thinking to them because they impress us. And we may end up running 100 simulations and we get something, the blue line that you can see, and we convince ourselves that the drift is less than 0.5% because we have done 100% analysis, we have done 100 simulations, and it's very sophisticated. But if you have a behavior like the blue line, in my opinion, you have to step back and think about it. I'd rather to do a few analyses and I can show that I have a behavior like the green line that I'm showing, rather than doing sophisticated things, and I swear that I know that everything will stop at the corner. Finally, because this is a session about seismic retrofit, I like to end with something that is related to something that concerns all of us, using two memorable pictures from the recent disasters that have affected United States. One is very recent. You've seen the building that resisted and stood tall after the recent hurricane in Florida. The other one is from Katrina, a little bit older. Number one, despite the normalcy bias that we have, we see every day that bad things happen. And now with the access to the information that comes through every day, multiple times, we can't really let this to defeat us. We have to defeat this bias of normalcy to be able to defeat the earthquakes. We see that every day. And also pay attention to the conversation that is happening. There is this debate, how many people died during the hurricane in Puerto Rico? Is it 60 or 3,600? The political debate aside, this is a question for us too. We heard from one of the speakers that the question of life safety and collapse prevention is like how you feel when you want to go and reconnaissance the building. Another question that I ask is, when we talk about life safety, is it only during the event, or what happens to the lives after an earthquake? In New Zealand, they have learned like the rate of suicide has tripled in 6 or 7 months after the earthquake, in something similar to that. So our responsibility is it just saving lives in 60 seconds of earthquakes, or coming up with design that save lives in the aftermath of earthquake? The second thing, it has been shown repeatedly that prevention is less expensive than rebuilding. And I constructed an example that correlates with reality. It was hypothetical, but again, $0.75 million could reduce the loss so much. And finally, I think these pictures, as impressive as they are a reminder that when we pursue to be resilient, this is not a matter for individuals. This is a community level. If you think about these buildings, they achieved what is intended. But in terms of being resilient, staying over there, real estate, accessibility, function, none of those have been achieved. So to be resilient is the work of all of us. And I hope that this leaves you with this food for thought to go out and talk to other people about our responsibility to work towards that resiliency. Before I finish, I just want to also acknowledge people who have helped me. Dr. Jalalpour is my coworker who did all of the responses to analysis, nonlinear analysis. Bill Graft with ImageCat consulted about the loss estimate. Sergio was kind enough to point me to all of the results of all of his research, and people in Europe, San Francisco, who allowed me to use their loss estimate platform. Thank you so much.